Hello, today we'll be covering the last 5 problems of the 2014 AMC 8. First up, problem 21. We have two 7-digit numbers, 74A52B1 and 326AB4C, and we're given that each are multiples of 3, and it wants us to find which of the following could be a value of C. So first, we note that the sum of the digits of both numbers has to be divisible by 3 because this is our divisibility rule for 3. So then we have the sum of the digits of the first number, which is 19 plus A plus B must be divisible by 3. And the sum of the digits of the second number, which is 15 plus A plus B plus C, must also be divisible by 3. Thus, 19 plus A plus B must be congruent to 0 mod 3, and so 15 plus A plus B must be congruent to -4, which is congruent to 2 mod 3. Now a little reminder on how mods work. A congruent to B mod C means that when you divide A by C, you're left with a remainder of B. So since 19 plus A plus B is divisible by 3, we're left with a remainder of 0. We can subtract 4 from each side, and -4 acts the same as a 2, because essentially -4 minus 2 is -6, which in the world of mods we consider to be divisible by 3. And then we have 15 plus A plus B plus C then has to be equal to 2 plus C mod 3, and thus C must be congruent to 1 mod 3. This is because we have that 15 plus A plus B plus C must be divisible by 3. Therefore, it must be congruent to 0 mod 3. And thus, 2 plus C must be congruent to 0 mod 3. And clearly, if C equals 1, or is congruent to 1 mod 3, 2 plus C, which would be 2 plus 1, would be 3, which is congruent to 0 mod 3, and our condition would be satisfied. Therefore, 3. So then finally, we can figure out that C has to be 1, 4, or 7, and the only one of these answer choices we're given is 1. Problem 22. We have a 2-digit number such that the product of the digits plus the sum of the digits is equal to the number. It wants us to find the units digit. So, let this number be 10A plus B, where A is the tens digit and B is the units digit. Then the problem tells us that AB plus A plus B is equal to 10A plus B. We can subtract A plus B from each side of the equation to get AB equals 10A minus A, which equals 9A. And then assuming A is not 0, which the problem gives us since it's a 2-digit number, we can divide by A to get B equals 9. And thus our answer is E. Now, problem 23 is quite a long one. For the sake of time, I'm not going to read it, but I'll leave it up here for a couple of seconds so you can reference it. So to solve it, we note that the greatest number any of their two uniform numbers can be is 31. That's because they reference dates within a month, and if the largest the sum of their two can be is a date later this month, it clearly cannot be any greater than 31, since no month has more than 31 days. Now, obviously, none of their numbers are greater than 20, because all of their numbers are 2-digit numbers. So if you had something greater than 20, plus another 2-digit number, you're gonna have something greater than 31 if both are prime, because the greatest prime number greater than 20 is 23, and then 23 plus 11 gives you 34, which doesn't work. Also, two of them cannot have the numbers 17 and 19. If they did, then these two would have a sum of 36, which is greater than 31, and thus invalid. So, let Ashley's number be A, Bethany's be B, and Caitlin's be C. They always do the naming like this, it's quite nice for the variables. By the previous conditions, their numbers can be 11, 13, and 17, or 19, but not both. From the conditions the problem gave us, we have that A plus C equals a date earlier this month, A plus B equals a date later this month, and B plus C equals today's date. Thus we have this inequality, because a date earlier this month is clearly less than today's date, which is clearly less than a date later this month. So we can figure this out by seeing that the greatest term of the inequality, A plus B, doesn't include a c in it. Thus, c must be less than the other two, because b plus c is less than b plus a, and a plus c is less than a plus b. So now out of a and b, which is the greatest? Well, we have a plus c is less than b plus c, so a has to be less than b. Thus, Caitlin, who is c, has to have the smallest number, which we figured out earlier, to be 11. Problem 24. One day, the beverage barn sold 252 cans of soda to 100 customers, and every customer bought at least one can of soda. What is the maximum possible median number of cans of soda bought per customer on that day? So let the 100 customers have bought the following number of soda cans assorted from lowest to highest. C1, C2, so on to C100. Don't worry about the notation. It's just imagine the first customer bought C1, the second customer bought C2 amount of cans, and so on. So our median is then C50 plus C51 over 2, because we assorted this list from lowest to highest, and we have that the definition of a median is the middle number, or if it's an even amount, the middle two numbers averaged, and that would be this in our case. Thus, we want to maximize C50 and C51. So let C1 through C49 be 1, which is the minimum allowable number. Then we have that the sum of the remaining 51 has to be 252 minus 49, which is 203. So we notice that 4 times 51 is 204, which would have been mightily convenient, because then we can just let all 51 of those customers have bought 4 cans and we're done. But that doesn't work. So we can let 53 of the customers have bought 4 cans, and the last unlucky guy, which for us is C50, bought 3 cans. Thus our median has to be 3 plus 4, because we have C50 plus C51, over 2, which is 3.5. Finally, problem 25. We have that a straight 1-mile stretch of highway, 40 feet wide, is closed. Robert rides his bike on a path composed of semicircles as shown. If he rides at 5 miles per hour, how many hours will it take to cover the 1-mile stretch? So, in the upper right we have what we'll refer to as figure 1. So each semicircle has a radius of 20 feet, since each semicircle has a radius equal to half of the road's width. So Robert bikes a total of 132 semicircles to cover a mile. Because each semicircle he bikes, he goes in linear distance, the distance of the diameter of the semicircle, which is its radius times 2, which is 40 feet. Now for each semicircle he bikes its outer rim, outer circumference. Now since for a circle the circumference is 2 pi r, for a semicircle it'll be half of a circle, so it'll just be pi r, which in our case is equal to 20 pi feet. So we have that in total he bikes 20 pi times 132, which equals 2640 pi feet, because he bikes 132 semicircles and 20 pi feet per semicircle. Also, the problem gives us that he bikes at 5 miles per hour, which equals 5 times 5280 feet per hour, which equals 26400 feet per hour. Finally, note that distance equals rate times time, so time equals distance over rate, and so the time in our case equals 2640 pi, the distance, over 26400, the rate, which is pi over 10 hours. Thank you, and I hope you enjoyed these last 5 problems from the 2014 AMC 8.